Hello and welcome back. Do you really think you know quadratic formula or you are just using it? Today we will cover four key points in this video. Why it is the best to solve with, its construction, its derivation, and some examples. Let's begin. When solving quadratic equations, you have options like factoring, completing the square, or using quadratic formula. But here is why quadratic formula dominates the competition. First, we have applicability. It works for all quadratic equation. The quadratic formula can solve any quadratic equation regardless of whether it can factored easily or not. Complex root. It can handle cases where the roots are complex or non-real, which factorization cannot. Next, simplicity. Less trial and errors. Factorization often requires guessing factors, which can be time-consuming and may not always lead to a solution. Another thing is just direct calculation. Quadratic formula provides a straightforward calculation without needing to find factors. 3. Efficiency. It's fewer steps. Quadratic formula typically involve fewer steps, especially for higher degree polynomials or those with large coefficients. And the consistent method. It provides a consistent method for solving quadratics, making it easier to apply in various contexts. 4. Numerical stability. It's avoiding errors. The quadratic formula can reduce the chance of making arithmetic errors that might occur during factorization process. 5. Understanding of roots. Don't be scared over here. We can explain it very well. Discriminant insight. The discriminant in the quadratic formula give immediate insight into the nature of roots. Two distinct real roots, one real roots, or two complex roots. Our conclusion from here, while factorization can be quicker for simple quadratic, the quadratic formula is more reliable and versatile, making it a preferred method in many situations. I will guide you through the derivation steps for quadratic formula. We begin with the standard form of a quadratic equation, which is expressed as ax squared plus bx plus c is equal to 0. This will be our starting point. Step 1. Simplify the equation. We will divide the entire equation by a. So we are going to have x squared plus bx over a plus c over a is equal to 0. Step 2, we're gonna rearrange the terms. We are going to bring c over a term to the other side. So we're gonna end with x squared plus b over ax equal to negative c over a. Step 3, completing the square. If you are wondering about this method, you can check my video over there for 3 methods for how to solve a quadratic equation. To do this, we are going to add b over 2a power 2 to both sides of the equation. So we're gonna end with x power 2 plus b over ax plus b over 2a square equal to negative c over a. We're gonna add the same term out there plus b over 2a also square. Step number 4. We're gonna factor the left side. In this case, it is x power 2 plus b over ax plus b over 2a. Now, again, if you are wondering about the factoring method, you can check this video out there. We are having over here x plus multiplied by also x plus. Now, let's check this term over here and this term over here. Now, this is a squared, so this is a perfect square, which is, I think, a little bit obvious. So this will be b over 2a. And this will be also b over 2a. Since they are perfect square, we can put it in one bracket and square this bracket. So step number 4 again is factoring the left side. X plus b over 2a, all of this side square, equal to negative c over a plus b over 2a squared. We can also do something over here. We can combine these two terms over here. If we're gonna apply the power to 2 to this bracket, we're gonna end with by combining the two fractions. So from here, we're gonna have b squared over 4a squared, and from the other fraction, we're gonna multiply it by 4a up and down. So we're gonna have negative 4ac over 4a squared, and that will lead us to b squared minus 4ac over 4a power 2. So we can rewrite it now as x plus b over 2a, all of this squared, equal to b squared minus 4ac over 4a squared. Step number 5, we are going to take the square root of both sides. So all we're gonna have to do to square root this bracket and to square root this fraction. And we're gonna end with x plus b over 2a equal to square root of b squared minus 4ac over square root only this part. This will end with 2a. And it will end with actually positive or minus 2a. And it will not hurt if we put the positive or minus up there instead of the denominator. The last step, we're gonna solve for x. So we are going to have on this side, x is equal to, we're gonna bring this term to the other side, and we're gonna have negative b over 2a plus or minus square root of b squared minus 4ac over 2a. We can combine these super easily. We're gonna have negative b plus and minus square root of b squared minus 4ac over 2a. And we can say, voila. This is the derivation for the quadratic formula that we all are looking for. Super systematic and super basic and super simple. Just follow the steps. Next, the construction of quadratic formula. So we're gonna take each part in this equation and explain it and why it's useful to use it. First thing that we have is negative b, which is the opposite for the coefficient of x. And it's benefit for us because it helps to shift the parabola, which is the graph of quadratic equation, horizontally. Next, we are having the plus or minus sign, which indicate for us that usually we're gonna have two solutions for the quadratic equation. It tells you to calculate the formula twice, once with addition and one with subtraction. Number 3 is b squared minus 4ac. And we call this term the discriminant. And this is one of the most important things in the construction of quadratic formula. So it has 3 cases. The first case that it is positive. And if it is positive, this means that you have 2 real solutions. In the other case, if it is equal to 0, and this means that you have 1 real solution or a repeated root, or you can say it in another way, 2 equal roots. The third case, if it was negative, this means that you have 2 complex or imaginary solutions. The discriminant, it helps you understand what kind of answer to expect before you even finish the calculation. I want to give you an example about if it was negative. So let's assume that b squared minus 4ac is equal to negative 4. This is the case when b squared minus 4ac is less than 0 or equal to a negative number. This will lead us to a 2 complex imaginary solution, and here I'm gonna show you the source of where it came from. So when we have negative 4 underneath the square root, you need to separate the negative from the number. So you're gonna have negative 1 multiplied by 4. In this case, you can find the square root of 4, but you cannot find the square root of negative 1. So you're gonna have 2 outside of the square and a square root of negative 1. Now, this part, negative 1, is the imaginary part, and we call it I or j or I. And then you're gonna write this 2i or 2j. Some books use the j, some books use the I. This will lead us to have 2 complex imaginary solutions. The I part, or the square root of negative 1, is called the imaginary part. Number 4, which is the 2a, and the last thing in the construction for quadratic formula, it is twice the coefficient for a in your equation, and it's used to scale the solution appropriately. So it's related more to graphing the equation. It's ensure that the solution are correctly positioned on the x-axis. And that's it for construction for quadratic formula. Next, the examples of using quadratic formula. And I'm gonna use 3 different examples. One that has 2 real solutions, one that has 1 real solution, and one that has 2 complex solutions. Let's start with the first one. So the first thing that I need you to do to extract A, B, and C. If you are a beginner or just starting using quadratic formula, do this first so everything is smooth and easy while you are solving. And do it slowly. seriously. We have a over here is equal to 1, b is equal to 5, and c is equal to 6. Now let's insert these in our equation. We're gonna have x is equal to negative b, so negative times 5, plus or minus square root of b squared minus 4 times a times c, 4 times 1 times 6, over 2 times a, which is 2 times 1. First, write everything. Next, you're gonna have x is equal to, now you can start the calculation. Negative 5 plus or minus square root 5 squared is equal to 25, minus 4 times 1 times 6 is equal to 24 over 2 times 1, which is equal to 2. This will lead us to negative 5 plus or minus square root 25 minus 24 is 1 over 2. Square root of 1 is just 1, so we are gonna have over here negative 5 plus or minus 1 over 2. So we're gonna do this in the two conditions that we have, one when it is positive and one when it is negative. So first we need negative 5 plus 1 over 2, and the next we're gonna need negative 5 minus 1 over 2. This will be equal to negative 5 plus 1 is negative 4 over 2 equal to negative 2. And here we're gonna have negative 5 minus 1 equal to negative 6 over 2, which is equal to negative 3. From the first equation, we're gonna have x is equal to negative 2 and negative 3. And from this solution, we are having two real solutions. Next one. We are having x squared minus 4x plus 4 is equal to 0. First, let's indicate our a is equal to 1 and b is equal to negative 4 and c is equal to 4. Let's insert this number in our equation. We are gonna have x is equal to negative b, so negative 4 plus or minus square root of b squared, so negative 4 inside a bracket, power to 2 minus 4 times a times c, 4 times 1 times 4, over 2a, which is 2 times 1. Let's start to calculate. We're gonna have x is equal to negative times negative. Over here, we're gonna have 4 plus or minus square root of negative 4 squared. All of the negative 4 is squared, so we're gonna have over here 16 minus 4 times 1 times 4, which is another 16. Over 2a, 2 times 1 is just 2. So from here, you can stop and take a look. You have a square root of 16 minus 16, which is 0. This means that we don't have plus or minus something. It will be plus or minus 0. This means that we have one real solution, or two repeated the same thing solution, or two equal solutions. So here is the point of you can have some information about the solution before the final calculation. So next, we're gonna have x is equal to 4 plus or minus root 0, which is 0 over 2, so this will be equal to 4 over 2, which is equal to 2. X is equal to 2, and this is called one real solution or repeated solution because we have two things. So you can write it in x is equal to 2 and 2. Example number 3, x squared plus 2x plus 5. First, a is equal to 1, b is equal to 2, and c is equal to 5. Let's insert this in our equation. We are gonna have x is equal to negative b, so negative 2 plus or minus square root of b squared 2 power 2 minus 4 times a times c, which is 5, and a is equal to 1 over 2 times a, so 2 times 1 again. So from here we can say that we are having negative 2 plus or minus square root of 2 power 2 is equal to 4 minus 2 times 1 times 5 is equal to 20 over 2 times 1, which is equal to 2. So you are gonna have negative 2 plus or minus root 4 minus 20 is negative 16, and from here you can see what actually do we have. So we're gonna have a square root of negative something, whatever this thing is. This means that we're gonna have a complex root or non-imaginary root. Next, so we will need to calculate x in two cases when x is equal to negative 2 plus or minus square root of negative 16. So let's take this outside a little bit and let's see what does this mean. Square root of negative 16, as we said before, we need to separate between the negative and the numbers. Then we're gonna have negative 1 multiplied by 16. 16 square root of 16 will be equal to 4 root 1 root negative 1, and this is the imaginary part or the complex part that we are having over here. So we can write over here 4 root of negative 1 over 2. We can separate between these two and let's divide first. So we're gonna have negative 2 over 2 plus or minus 4 of root 1 over 2. This will be equal to negative 1 plus or minus 2 root 1. And that's it. So your solution will be 1 with plus and 1 with minus. And in this case, we cannot combine the numbers. If you have an imaginary number or a complex number, you cannot combine it by adding it to anything, by multiplication or division. So the x will be equal to, over here, -1 plus 2 root of -1 plus or minus. It can also be written as -1 plus or minus 2i. Okay? It can also be written as x will be equal to, it can also be written as x is equal to -1 plus 2i and -1 minus 2i. And by this, we had two complex solutions. And by this, we are done with examples of quadratic formula. The first one was 2 real solution, and second one was 1 real solution or 2 repeated solution, and the last one was 2 complex solution. If you have any question, leave it in the comment, like and subscribe, and thank you for watching. Please have a good, amazing day.